Chapter 1. Before the red flag, there was a Soviet key. In 1960, a fleet of Soviet military advisors packed their bags and left China. They took their manuals, their expertise, and, in many cases, their unfinished work. What they left behind was a country with half-built weapons it did not fully understand, and a leadership that had just learned the most important lesson of modern defense. No nation can protect its skies if another country controls the lock. What followed over the next 6 decades was one of the most determined, methodical, and often underestimated military technology programs in history. China built, copied, reverse-engineered, and eventually surpassed its teachers. It went from firing Soviet-designed missiles at Taiwanese reconnaissance planes to fielding systems capable of reaching satellites in low Earth orbit. This is every surface-to-air missile system China ever built under the red flag designation, from the first licensed copy delivered in 1959 to the anti-satellite interceptors paraded in 2025. 17 systems, 6 decades, and a transformation that reshaped the global balance of air power. Some of these systems are well documented. Others are barely known outside classified briefings. All of them tell the same story: a nation that refused to depend on anyone else for its own defense. Chapter 2. The Soviet Blueprint, Red Flag 1 and Red Flag 2. In 1959, Mao Zedong made a personal request to Nikita Khrushchev. He wanted the SA-75 Dvina, the Soviet surface-to-air missile system that had just shot down an American U-2 spy plane over Sverdlovsk. Despite a relationship between the two countries that was already cooling, Khrushchev agreed. 5 fire divisions arrived in China that year, 62 V-750 missiles, a team of Soviet advisors, and a license to produce the system domestically. That license became the HQ-1, HongQi 1, meaning Red Banner 1, the first surface-to-air missile ever fielded by the People's Liberation Army. The HQ-1 was a direct copy of the SA-75. Same fan-song engagement radar, same command guidance system that tracked both the missile and the target simultaneously and steered the missile onto an intercept course. Maximum range of around 34 kilometers, altitude ceiling near 27 kilometers. Against high-flying reconnaissance aircraft, it worked. But in 1960, everything changed. Moscow recalled every Soviet advisor from China, almost overnight. The technical cooperation that was supposed to make the HQ-1 production line operational was cut off before it was finished. Chinese engineers were left holding incomplete documentation and a weapon they had not yet fully mastered. They finished it anyway, and then they improved it. The upgrade became the HQ-2. It kept the liquid-fueled 2-stage rocket motor of the Soviet original but added improved guidance electronics, a more powerful warhead, and better resistance to electronic jamming. The fan-song radar remained, but the processing behind it was Chinese. The HQ-2 proved itself in combat. During the 1960s, HQ-2 batteries shot down multiple Taiwanese U-2 aircraft, flying reconnaissance missions on behalf of the CIA. Each kill was a strategic message. China had denied a superpower the ability to look down at its territory from the edge of space. Over the following decades, the HQ-2 went through at least 5 distinct upgrade cycles: better guidance computers, improved radar, more capable motors. The final version, designated HQ-2J, incorporated digital command guidance with encryption, making the engagement link far harder to jam, and added an electro-optical tracking channel as a backup for when electronic warfare threatened the radar. The HQ-2J also exposed a serious operational limitation. During the 1979 Sino-Vietnamese War, HQ-2 batteries were fixed in place. Their coverage zones were static. Ground forces could only advance through corridors that fell inside the SAM umbrella. If you moved beyond it, you lost your air defense cover entirely. The system was powerful in defense and nearly useless in maneuver warfare. That lesson would shape everything that came after. Export versions of the HQ-2 series went to Iran, Pakistan, North Korea, and several other states, usually packaged with maintenance training and technology transfer. The HQ-2 remained China's primary strategic surface-to-air missile for more than 40 years. No other SAM in any major military served in its primary role for that long. It was finally replaced in frontline service by the HQ-22 after 2016. But before the replacement came, China had been building towards something else entirely. Chapter 3: Learning to Walk Alone. The First Indigenous Generation. The dependence on Soviet technology had one obvious solution: stop depending on Soviet technology. The effort to build a genuinely Chinese surface-to-air missile began in August 1965, when China's Central Military Commission issued a requirement for a domestically designed short to medium-range system. The project was internally codenamed HongQi 4-1. What emerged from it was the HQ-61. The HQ-61 represented a genuine departure. Where the HQ-1 and HQ-2 used command guidance, steering the missile from the ground radar, the HQ-61 used semi-active radar homing. The missile itself homed on radar energy reflected off the target. It was a more sophisticated approach, and it was entirely Chinese in concept. Development was not smooth. In September 1970, engineers discovered that a redesign had caused a dramatic drop in missile speed, for reasons that were not immediately understood. A complete third redesign was initiated in 1973 by the Second Electromechanical Bureau of Shanghai. The whole program had taken nearly a decade longer than planned. The final system included 1 search radar, 3 tracking and fire control radars, 1 power supply truck, and 6 transporter erector launchers. The battery architecture established a template that later Chinese SAM designs would follow. The HQ-61 also produced China's first domestically designed naval SAM. The HQ-61B was fitted aboard 4 Type 053 H-2G Jiangwei I frigates, built between 1988 and 1991. China's Navy had an indigenous shipborne SAM for the first time. The PLA Navy was not impressed. The HQ-61B was judged insufficient for modern naval combat and was replaced by a newer system. It was a candid admission. But the engineers who built the HQ-61 had also done something valuable in parallel. They developed an air-to-air version of the missile, designated PL-11, which would eventually become a foundation for China's beyond visual range air combat capability. That same basic seeker technology would also underpin the next chapter, which began not in a Chinese laboratory, but in France. While China was building the HQ-61, it was also watching the West. In the late 1970s, a window opened. Sino-Western relations had warmed enough that France sold China the Thomson CSF Crotale, a short-range, low-altitude SAM designed to destroy fast jets at close range. China bought it, studied it, and reproduced it. The result was the HQ-7. Reverse-engineered by the Changfeng Electromechanical Technology Design Institute, it entered service in the early 1980s. The Crotale used infrared tracking combined with a radio command uplink, a fundamentally different guidance architecture from anything China had built before. The HQ-7 replicated that architecture domestically. A standard HQ-7 battery was compact, 1 short-range surveillance radar, and 3 launchers, each carrying 4 to 8 missiles. Range was roughly 10 to 15 kilometers. It filled the low-altitude gap that the HQ-2 had never been designed to cover. The export version, designated FM-80, was sold to multiple customers in Africa and the Middle East, making it one of China's first commercially successful SAM exports. A navalized variant of the HQ-7 eventually replaced the HQ-61B aboard Chinese surface combatants, going to sea on Type 052 destroyers and Type 54A frigates. It was the French Crotale, reborn as a Chinese naval system. Around the same time, China was absorbing technology from another Western source. The Italian Selenia Aspide missile, itself derived from the American AIM-7 Sparrow, had been licensed for production in China as the PL-11 air-to-air round. That same technology became the foundation of a new ground-based SAM family, the HQ-6. Developed by the Shanghai Academy of Spaceflight Technology, the HQ-6 used semi-active radar homing and achieved a maximum speed of Mach 3, with an engagement envelope reaching 8 kilometers in altitude and 10 kilometers in slant range. Unlike the Italian Aspide, which used canister launchers, the HQ-6 used rail launchers, with 2 missiles on rails per truck-mounted launcher. An export variant designated LY-60, lying 60, meaning Falcon 60, was unveiled in October 1994. An upgraded domestic version, the HQ-64, passed state certification testing and entered Chinese military service as a mobile air defense node. The HQ-6 family was China's first SAM, built on a foundation of Western rather than Soviet technology. It would not be the last. Chapter 4. The Phased Array Revolution and the Russian Premium. By the 1990s, China had a portfolio of short-range SAMs with foreign lineage and a long-range system in the HQ-2 that was increasingly obsolete. Neither extreme was satisfying. What China needed was a capable, medium-range system built entirely on Chinese terms. It got that with the KS-1, also designated HQ-12. The Kaishan-1, or Mountain Opener, was the first Chinese air defense system ever equipped with a phased array radar. That distinction matters. A phased array radar electronically steers its beam, tracking multiple targets simultaneously with no moving parts, and is inherently more resistant to jamming and degradation than mechanically scanned systems. Every serious modern SAM has one. The HQ-12 was China's entry into that generation. Development was initiated as a replacement for the HQ-2. The requirements were clear: solid fuel propulsion instead of the HQ-2's hazardous liquid fuel motors, greater mobility, and a phased array engagement radar. A typical HQ-12 battery comprised one passive, phased array radar panel, 4 twin-rail launchers carrying 8 missiles, 16 reload missiles on support trucks, a command and control station, and generator vehicles. The missile had a mass of 900 kilograms, carried a 100-kilogram warhead, and reached a maximum speed of 1,200 meters per second. Slant range was 5 to 50 kilometers, with an altitude ceiling of 25 kilometers. In 2005, Malaysia signed a Memorandum of Understanding to purchase the export version, the KS-1A. The HQ-12 was confirmed at the PLA's 80th anniversary exhibition in 2007. Its lineage continued directly into the HQ-22, which Kasich developed as the medium to long-range successor more than a decade later. But while China was building the HQ-12, it was also doing something that would shortcut years of domestic development. It was buying Russian. Beginning in 1992, China imported the S-300 PMU from Russia, then the S-300 PMU-1. These were not the HQ-2 era of Soviet hand-me-downs. The S-300 PMU-1 was the most capable mobile long-range SAM available on the export market at the time, and China received it in quantity. In 1995, Russia granted China permission to license the S-300 PMU-1 for local designation and modification. The domestic Chinese designation became the HQ-15. It was publicly unveiled at the October 1999 parade, marking the 50th anniversary of the People's Republic of China, with batteries stationed prominently in the Eastern Coastal Defense Zone. A typical HQ-15 battery included the 64N6E Big Bird surveillance radar, which had an aperture 30% wider than the American SPY-1, alongside the clamshell acquisition radar and the flap-lid phased array engagement radar. The 48N6E missile used inertial guidance with active radar terminal homing and vertical cold launch. It could engage ballistic missiles with re-entry speeds up to 2.8 kilometers per second, placing the HQ-15 inches roughly the same category as the American PAC-2 Patriot. Each battalion operated up to 12 launch vehicles carrying 48 missiles and a single guidance station, with the ability to track and simultaneously engage 6 independent targets. 5 battalions were deployed and maintained in active duty around Beijing and Tianjin, specifically for capital defense. Additional battalions were stationed in Fujian Province, overlooking the Taiwan Strait. The S-300PMU-1 was not the only S-300 variant China acquired. In the early 2000s, China imported several examples of the S-300V, a fundamentally different system designed not to shoot down aircraft but to destroy American tactical ballistic missiles. The S-300V had no direct Western equivalent. The U.S. Air Force considered the F-22 Raptor its primary platform for suppressing S-300V batteries. Nothing else in the American inventory was judged survivable enough to do the job. China studied the S-300V and built its own version, the HQ-18, described in Chinese sources as a multifunctional, third-generation air defense missile system. The HQ-18 was assessed by Western analysts as superior in anti-ballistic missile performance to the American PAC-2 Patriot. Its phased array sector scan radar could track up to 16 targets simultaneously at a range of 175 kilometers. In 2010, Pakistan announced intent to purchase 4 HQ-18 systems. Chinese defense analysts projected that continued development of the HQ-18 would eventually lead it to replace the HQ-9 as the primary long-range missile defense platform. That prediction did not come to pass in a simple way. Because China was simultaneously building something else, something entirely its own, that would prove more consequential than either the HQ-15 or the HQ-18. Chapter 5. The Flagship, from Red Flag 9 to the Export Wars. The HQ-9 is the system that defined modern Chinese air defense. Its development started in the late 1980s, driven by a straightforward objective. China needed a long-range SAM it owned completely, designed and produced without Russian permission, without French technology transfers, without any dependence on foreign supply chains. The design drew on whatever intelligence China could gather. Western analysts looking at the finished product saw elements consistent with both the Russian S-300PMU and the American MIM-104 Patriot. China had clearly studied both systems with considerable thoroughness. But the HQ-9 was not a copy of either one. It was a synthesis, filtered through Chinese requirements and Chinese engineering. The HQ-9A variant achieved initial operational capability in 2001. Maximum engagement range was approximately 120 kilometers. Flight ceiling was 30 kilometers. The propulsion system used solid fuel, which meant the missile could sit in its canister, fully fueled and ready to fire, for years without maintenance, unlike the liquid-fueled HQ-2. The guidance system combined inertial navigation with mid-course command uplink and active radar terminal homing. A full HQ-9 battery, as deployed by the PLA, contains 48 missile launch vehicles, carrying 192 ready missiles, 6 targeting radar vehicles, 6 search radar vehicles, and full command and communications infrastructure. It is one of the most missile-dense SAM formations in the world. The missile itself weighs approximately 2,000 kilograms, carries a 180-kilogram warhead, and reaches speeds exceeding Mach 4. The export version, designated FD-2000, was unveiled at the Africa Aerospace and Defense Exhibition in Cape Town in March 2009. China marketed it as incorporating anti-stealth capability, a claim that generated considerable attention. In 2013, that claim got a real-world test. Turkey launched a competition for a national long-range air defense system, the FD-2000-1. Ankara selected a Chinese SAM over the American Patriot and the Russian S-400. NATO was alarmed. The prospect of a Chinese origin system, with all its associated Chinese radar frequencies, communications architecture, and potentially intelligence access, inside a NATO member state's air defense network was not acceptable. Diplomatic pressure built. By 2015, Ankara canceled the contract. The HQ-9 itself kept evolving. The HQ-9B extended maximum engagement range to approximately 260 kilometers, raised the flight ceiling to 50 kilometers for engagement of high-altitude targets, including some ballistic missiles, and introduced improved electronic countermeasures resistance. In a May 2021 exercise, an HQ-9B brigade deployed 500 kilometers from its home base in unfamiliar terrain, in darkness, in low temperatures and sandstorm conditions, and intercepted 4 UAV targets with 4 missiles, 1 shot per target. The demonstration was deliberate and public. A 2024 configuration went further. New launchers were revealed, carrying 8 smaller missiles per vehicle instead of the previous 4, doubling magazine capacity. The configuration was specifically optimized for mass drone and cruise missile attacks, the threat that has defined every major conflict since the mid-2010s. The HQ-9B is now assessed as the most widely produced long-range SAM system outside Russia. Export customers include Algeria, Pakistan, Iran, Iraq, Turkmenistan, and Uzbekistan. While the HQ-9 family covered the long range, China had a gap in the naval close-in domain. The HQ-7 could reach 15 kilometers. That was fine for a frigate guarding against subsonic threats. It was not adequate for an aircraft carrier or a modern destroyer facing saturation attacks from fast sea-skimming missiles. The solution was the HQ-10. Developed by the China Aerospace Science and Technology Corporation, the HQ-10 was first adopted aboard the Liaoning aircraft carrier and the Type 056 Corvette in 2011. It filled the same role as the American Rolling Airframe Missile, a short-range, passive, fire-and-forget terminal defense system using imaging infrared guidance. Once it leaves the launcher, it homes on heat with no radar required. The missile weighs 20 kilograms, measures 2 meters in length, carries a 3-kilogram warhead triggered by an infrared proximity fuse, and engages targets between 0.5 and 9 kilometers in range and between 1.5 meters and 6 kilometers in altitude. The system can fire within approximately 10 seconds of detection. Launcher configurations carrying 8, 15, 18, or 24 missiles can be scaled to different warship classes, making the HQ-10 the most widely deployed air defense system across China's modern surface combatant fleet by hull count. Chapter 6. Closing every gap: the mobile, the medium, and the layered fleet. By the late 1990s, China had identified a critical vulnerability in its ground-based air defense architecture. It had long-range systems in the HQ-9 and HQ-15. It had short-range systems in the HQ-7 and HQ-6 families. But the medium-altitude, medium-range band between roughly 20 and 70 kilometers was largely empty. An enemy air force that understood Chinese SAM coverage could exploit that gap systematically. The 1991 Gulf War had already demonstrated exactly what unchallenged air power could do to a ground force. China watched the destruction of the Iraqi army with close attention. The lesson was not lost on the People's Liberation Army Air Force, which declared advanced air defense a top modernization priority within months of the conflict ending. The answer to the medium-range gap was the HQ-16. Development began in 2005, assisted by Russia's Almaz Anti Corporation, and incorporating elements of the Buk missile system. The baseline HQ-16 entered service in 2008, produced by the Shanghai Academy of Spaceflight Technology. Initial engagement range was 40 kilometers. The HQ-16A, which entered service in 2011, extended that range while improving low-altitude performance, with a minimum intercept altitude of just 15 meters, lower than any comparable system then in service. The HQ-16B pushed maximum range to 70 kilometers. The most capable export version, the HQ-16FE, reached a maximum slant range of 160 kilometers and an altitude ceiling of 27 kilometers. That is a 300% range increase from the baseline design within a single family over roughly a decade of development. The HQ-16 was simultaneously developed as a naval variant, the HHQ-16, equipping the Type 54A frigate and the Type 52D destroyer with vertical launch cells. Pakistan operates the export version under the designation LY-80, which entered service with the Pakistan Army in March 2017. China and Russia are the only two nations on Earth that have successfully exported medium-range SAMs in both naval and land-based configurations to the same foreign customer simultaneously. While China was filling the medium-range gap, it was also closing a different vulnerability: the low-altitude, very short-range domain used by attack helicopters, fast drones, and terrain-following cruise missiles. The solution came from Russia again, but not through purchase. Around 2000, China approached Moscow about licensing the Tor-M1, a tracked, vertically launched, short-range SAM, with a reaction time under 10 seconds. Russia said no. China reverse-engineered it anyway. The result was the HQ-17, incorporated into PLA Army service around early 2013, with its existence confirmed by the Chinese military in 2015. The missile weighed approximately 165 kilograms, measured 2.9 meters, and carried a 15-kilogram fragmentation warhead. Engagement envelope was 1.5 to 20 kilometers in range and 10 meters to 10 kilometers in altitude. Maximum speed was Mach 3. In 2019, at China's 70th anniversary parade, a new variant appeared, the HQ-17A. It had abandoned the original tracked chassis of the Tor-M1 and moved to a 6x, 6-wheeled platform. That change mattered. Wheeled systems are faster to deploy, easier to maintain, and more survivable in rapid maneuver scenarios. The HQ-17A could also fire on the move, something the tracked version could not reliably do. China cleared the export version, the HQ-17AE, for international sales in March 2021. The marketing positioned it explicitly against the growing drone and cruise missile threat. 1 year later, at Airshow China 2022, China unveiled the HQ-11, a step beyond the HQ-17 that no other military had previously attempted at production scale. The HQ-11 combined a SAM launcher and a high-rate cannon on a single integrated battery. The missile launcher vehicle used an 8x, 8-wheeled transporter carrying 8 vertical launch cells. It operated alongside an LD-3000, the Type 1130 close-in weapon system, a 30mm rotary cannon capable of over 10,000 rounds per minute, and a dedicated radar surveillance vehicle. 3 vehicles, 1 battery, capable of engaging incoming threats with missiles at medium distance and cannon at close range simultaneously. The official Chinese designation for the HQ-11 was the Universal Terminal Defense System. It entered PLA service in 2022, designed explicitly for saturation attack scenarios where dozens of drones and missiles arrive simultaneously from multiple vectors. Chapter 7. The Ceiling Has No Limit. Exo-atmospheric China. The history of the HQ family is, in one reading, a story of range. The HQ-1 reached 34 kilometers. The HQ-9B reached 260 kilometers. The HQ-22, which entered PLAAF service in 2019 as the direct replacement for the 40-year-old HQ-2, reached 170 kilometers for the domestic variant and 100 kilometers for the FK3 export version. Serbia purchased the FK3 inches 2019. rejecting the Russians' 300 inches the process. It was delivered by PLAF Xian Y-20 transport aircraft in April 2022, the first Chinese medium-range or long-range air defense system ever exported to Europe. The HQ-22 used the same 8x8-wheeled TEL architecture established by its predecessors, carried a 400-pound warhead, and reached a maximum intercept altitude of 88,500 feet. It was designed to be affordable, mobile, and decisive against the class of targets that the HQ-2 had spent 4 decades defending against. But by 2018, the boundary of Chinese air defense had moved somewhere the HQ-2 could never have reached. The HQ-19 entered PLA service in 2018, derived from the HQ-9 family but designed for a completely different mission. Its targets were not aircraft. Its targets were ballistic missiles, hypersonic glide vehicles, and satellites. The stated operational range was 3,000 kilometers. The flight altitude was 200 kilometers, which is above the International Space Station. Maximum interceptor speed was approximately 10 kilometers per second, faster than any ballistic missile target it would be called upon to intercept. The defeat mechanism was kinetic energy. The HQ-19 did not explode near its target. It hit it. The system used the TAS-5380 Transporter Erector Launcher, a road-mobile platform. China's first exo-atmospheric interceptor could be moved anywhere in the country, hidden, repositioned, and hidden again. This was not a fixed missile defense site like the American ground-based interceptors in Alaska. It was a mobile, anti-satellite, and anti-ballistic missile capability that could be anywhere. In 2025, China went a step further. The HQ-20 made its debut at the China Victory Day Parade, a medium to long-range system derived from the HQ-16 family, with a stated operational range of 160 kilometers and an altitude ceiling of 25 kilometers, using the newer TAS-5450 Transporter Erector Launcher. It represented China's latest effort to refresh the medium-range layer against stealth aircraft and hypersonic threats, filling the same band that the HQ-16 had opened up, but with sensors and missile seeker technology a generation more advanced. At the same parade, the HQ-29 appeared. Developed from the HQ-19, it was declared in service in 2025 as a dedicated anti-ballistic missile and anti-satellite weapon system with a stated engagement altitude of 100 to 2,000 kilometers. The upper end of that range is well beyond geostationary orbit. The HQ-29 shared the TAS-5380 launcher of the HQ-19, the same road-mobile platform, the same ability to move and vanish. No other surface-to-air missile family in the world explicitly and simultaneously covers both theater ballistic missile defense and low Earth orbit satellite interdiction within a single declared mobile system. From a copied SA 75 inches 1959 to a mobile anti-satellite system in 2025, the HQ family traveled a distance that most defense establishments never traverse in a century: 17 systems. 6 decades, a consistent principle that never changed. When someone will not sell you what you need, build it yourself, and when you have built it, make it better than what you were denied. The skies over China are no longer defended by Soviet technology. They are defended by something that started as Soviet technology, and long ago became something else entirely.